Okay, in this video we are, this is the 7.3a 6.5 practice conditions for rhombuses, rectangles, and squares. So let's see what we got here. Can you conclude from that the parallelogram is a rhombus, a rectangle, or a square based on what they give us? So let's see. Remember, rhombuses, all sides are congruent. Diagonals are perpendicular bisectors of each other. Also, the diagonals bisect the vertex angles. Rectangle, parallelogram with a right angle, and diagonals are congruent. And a square is a rhombus and a rectangle. So it's a rhombus, all the properties of a rhombus, and also all the properties of a rectangle. So let's see. So it's not rectangle or square. Let's see if this is a rhombus. What we have here is opposite sides parallel to each other. And this one diagonal does bisect these vertex angles, but in a rhombus, in a square, the diagonals are going to be congruent. This could be a rhombus. Let's see what we got. So we got alternate interior angles. These angles are congruent, parallel. So alternate interior angles are congruent. So let's mark up what we can see here. So this angle and this angle are going to be congruent. And going the other way, this angle and this angle are going to be congruent. Going, we do these two parallels. These are same side interior angles are supplementary. Going with this way. And same thing here. So these angles are also going to be congruent, which makes it a parallelogram. So you draw this diagonal through here. I don't think we can do anything with this one because there's nothing that guarantees that all these sides are going to be congruent to each other. I don't know if we could. Let's see, what could we use? Angle. Go this way. Okay, going this way, we got this angle and this angle congruent. And going this way, we get this angle and this angle congruent. But there's nothing, let's see, this one dotted angle is bisected. I'm not sure about this one. There's a possibility it sort of looks like these angles are all congruent to each other. We got vertical angles there, but I'm leaning towards it's not. It might be a rhombus, but it's not really. It would take a lot of work to prove it that it's a rhombus. Let's look at number 2. For number 2, we've got opposite sides parallel to each other. So that means it's a parallelogram. They're showing us the diagonals. They're not showing us any right angles. We got like these alternate interior angles are going to be congruent. Those alternate interior angles going this way are going to be congruent. These are going to be congruent this way with this one. And this one is going to be congruent to that one. But there's not enough to make it a rhombus. There's no right angles to make it a rectangle. There's not enough to prove that these are all, do have vertical angles here and there. But it doesn't show us anything about these angles being bisected for sure or anything like that. It doesn't mark the diagonals as being the same length. So again, I don't think there's enough information for this one. Let's look over here. Now here they're showing us that the diagonals are crossing at a right angle, so they're perpendicular to each other. That's one of the properties of a rhombus. Opposite sides parallel. I would lean to this being a rhombus because it's a parallelogram that has diagonals that are perpendicular to each other. So I would lean towards that being a rhombus. There's nothing about the angles being right, so we can't say anything about it being a square. Let's look here. NP is congruent to OQ, so this segment is congruent to this segment. Doesn't say anything about them bisecting each other, but the diagonals are congruent, and it's a parallelogram. This is probably a rectangle, even though they don't have the right angle marked. Because these diagonals are congruent to each other, a rectangle has diagonals that are congruent. It's most likely a rectangle. Let's look at number 5. For what value of x is the figure of the special parallelogram? So they want number 5 to be a rhombus. If it was a rhombus, this diagonal would bisect these two angles. So I can set these two equal to each other and find the x that would make it so. So we have 6x plus 32 equals 17x minus 1. If I take away 32 from both sides and take away 17x from both sides, I get minus 11x is minus 33, so x is going to be 3. So if x was 3, these two angles would be equal to each other, which would mean that this diagonal here would be a bisector, and that would make it a rhombus. Over here, same idea. If these two angles if this angle is bisected, then each one of these would be equal to each other, and that would be what we would have with a rhombus. So 4x would have to equal 3x plus 12. Take 3x away from both sides. X is equal to 12 for that one. Excuse me. For number 7, we want to make this a rectangle. So the length says that QS is congruent to TR, and so the diagonals need to bisect each other and also be congruent, but to bisect each other is this part. So we have 2x plus 6 equals 3x minus 6. Take 3x away from both sides, minus x equals minus 12, x equals 12. If x was 12, that would be a rectangle. Let's look at number 8. They want us to see what we can do to turn number 8 into a rhombus. So let's see, we got the measure of MPN, M to P to N, this angle here. To measure this angle here, they're saying is 110 degrees. Okay, this is a 5x. They want it to be a rhombus. This is 110, MPN. This one here also has to be 110. Because the diagonal would bisect it. That gives us 220. The two 110s. Now 360 is what all these degrees have to add up to. So if we take the difference, we get 140. Divided by 2, you get 70. Each one of these angles at M and O have to be 70 degrees. Half of that is a 5x. So we could look at this other side also being a 5x. So we have 10 x's is equal to 70. Which means that x would be equal to 7. If x was equal to 7, this angle would be congruent. And we've already got that this is 110. And altogether, the angles would add up to 360 degrees. So that would make it a rhombus. Let's look at number 9. We've got rectangles. Rectangles, they're congruent. They're not saying that they're congruent, but rectangles bisect each other. So this 6x minus 3 would have to equal 5x. Take 6x away from both sides, minus 3 equals minus x, divide by negative 1, x equals 3. If x, they're telling us also the diagonals are congruent, which makes it a rectangle. If x was equal to 3, then that would work out, and those would be the same size, which would deal with these diagonals being bisectors of each other. Here we want to do the same thing. MB, the two diagonals are congruent. And that means these, since they bisect each other, or since they need to bisect each other, means that these equal. We have 7x minus 2 equals 5x plus 16. Add 2 to both sides. Take 5x away from both sides. We have 2x's is equal to 18, or x is equal to 9. So if x was 9, these two would be equal to each other, which would mean that the congruent diagonals bisected each other, which would be what we need to have a rectangle. Let's look down here at number 11. Given two segments with lengths x and y, where they're not congruent, what special parallelograms meet the given conditions? One diagonal has length x. So diagonals intersecting at right angles. One of them is longer than the other. But because they intersect at right angles, that meets the definition of a rhombus. Let's look at number 12. Both diagonals have length y and do not intersect at right angles. So this is one diagonal. Make the same length. So here's the other diagonal. And if we kind of draw the shape that goes with that, we get this. And it's saying that both these diagonals are congruent. That is what we need to have a rectangle.